If you're looking at this first graph, I'm starting with an acid. You know that I'm an acid because you have a very low pH. You have a pH that is closer to 0 than it is to 7, or I should say 14. And when you add the base, at the very beginning of a titration, it will rise slowly, and then when you get close to the equivalence point, it will begin to rapidly increase. With this second graph here, you can tell that we're starting at a pH of high, probably close to 14 maybe, and that's going to be a base, and it will then go down as you've added acids. And that's how you can tell that you're titrating a base. So from the previous screen, when reading a titration curve, you can either have an acid being titrated with a base or a base being titrated with an acid. Looking at the graphs below, which is which? So think, look. If you said that the left one is an acid being titrated with a base, then you're correct, and you can tell because we start at a very low pH and end at a high pH. So therefore, this one, you started at a base, you're being titrated down to an acidic pH. So the equivalence point for this graph is at 7. So that's when it's been neutralized. When it occurs at 7, that means that you are titrating a strong acid with a strong base. For the graph below, you have to figure out in which a base is being added to an acid, which is the stronger acid, number 1 or number 2. So how would you know? For example, if you titrate ammonia solution with hydrochloric acid, you would get ammonium chloride formed. The ammonium ion is slightly acidic, and so pure ammonium chloride has a slightly acidic pH. That means that at the equivalent point, where you'd mixed the solutions in the correct proportions according to the equation, the solution wouldn't actually be neutral. To use the term neutral point in this context would be misleading. It would be slightly acidic. Similarly, if you titrate sodium hydroxide solution with ethanoic acid, at the equivalence point of pure sodium ethanoate, it's going to be slightly alkaline, which means basic. So it'd have a slightly alkaline pH, because the ethanoate ion is slightly basic. So you have to see if it's strong acid, strong base, then it's going to be 7. If it's a weak acid, strong base, it's going to be slightly above 7. If it's a strong acid and a weak base, it's going to be slightly below 7. So getting back to this question, which is the strong acid? Number 1 or number 2? And you will see on the next slide.